Hello and welcome to this lecture on creating a bar chart with Python. Let's get right to it. The first order of business is to import the libraries we'll need to create our bar chart. The two essential packages for us are Pandas and Matplotlib. Let's import Pandas as PD. Pandas is a widely used library for data analysis and is what we'll rely on for handling our data. Then we will also import matplotlib.pyplot as PLT. Matplotlib is the library we'll be using for visualization. Okay, now that we're all set, we can proceed with loading our data set. We'll name our first variable df_used_cars and use the pandas read_csv method to load our CSV file. Our file is called barchartdata.csv. If your dataset isn't in the same directory as your Jupyter Notebook, you'll need to specify the exact file location. For instance, if I were to use the exact path, my code would look like this. Here, it is important to indicate the path with forward slashes between the folder names. This is counterintuitive, as the path locations in your Windows or Mac are always specified with backward slashes. However, in Python, a backward slash has a different meaning. It is an escape character and can be used in conjunction with other symbols. Therefore, always remember to use only forward slashes when specifying a path to a file. Good. After we've loaded the CSV file, we can check what the data frame of used cars contains. It looks identical to the dataset we have already examined. Now let's see how we can translate this information in the form of a bar chart. Luckily, the pyplot module from Matplotlib has a readily available bar plot function. We'll need to type plt.bar. Before we go any further, let's hold Shift and press the Tab button. A window appears allowing us to explore the different parameters of the function. Unsurprisingly, the first parameter is the x-axis. The second, called height, is the y-axis, and so on. We can expand the window with the plus sign and scroll through. Alternatively, we can access a detailed description of functions and parameters through Matplotlib's online documentation. For our bar chart, we'd like to plot the number of car listings by brand. Therefore, for the x-axis, we should select the brand column from the cars listing variable. On the y-axis, which is the height, we'll need the number of cars sold. Hence, from our used cars data frame, we'll take the second column, cars listings. Also, as the last line, we ought to include plt.show to ensure we're able to see our plot, no matter which environment we use. All right. Let's run the cell and check the result. Look at that. Only a line or so of code is all that's required to create a bar chart. Good job! Now, although this chart is displaying the correct information, we can still improve its appearance. Data visualization is not only about creating a chart, but also styling it in a compelling way. Therefore, let's spend some time on that too. With each visualization we create in this course, our final goal would be to reach a professional graph with some widely accepted dimensions and colors. So let's get straight to it. First things first, we want to be able to read all the labels on our x-axis, and at the moment they are overlapping. We can resolve the issue by increasing the size of the plot. The default size is 6.4 by 4.8 inches. We could increase it by specifying the size through the fig size parameter. From my experience, a 9 by 6 figure will be appropriate for most visualizations. Excellent! But there is another way as well. We can avoid overlapping labels by rotating them. Let's try it out, shall we? We'll just introduce an additional line of code, plt.xticks, with a rotation angle of 45 degrees. And here's the result. Rotating labels is an easy way to utilize space without changing anything else in the plot. Now that that's out of the way, let's enhance our chart a bit more. So far, we've been working with Matplotlib, which as a visualization library has a default setting for chart formatting, including font, font size, background themes, etc. Sadly, this particular look isn't everyone's cup of tea. Not long ago, a new visualization library called Seaborn has emerged and has become the preferred choice for many programmers, especially in the field of data science. Seaborn is actually built on top of Matplotlib. As such, the two libraries can be seamlessly integrated and work alongside each other, which is great news for us. To be more precise, we can import Seaborn and set its look to overwrite the default one in Matplotlib. Let's scroll back to the top of our code and try it out. First, we'll import Seaborn as SNS, and secondly, we'll overwrite the Matplotlib look with sns.set to take advantage of the Seaborn styling. In essence, this will allow us to code the graphs in Matplotlib, but they will be displayed with what some call the much superior Seaborn look. Alright, it's time to put it to test by rerunning the last cell of code. Tremendous! Moving forward, we'll be sticking with the Seaborn visuals in the majority of cases. What's next on the agenda? Generally, data visualizations convey insights through shape and color. While the shape is somewhat restricted by the nature of the data, the color is up to us. Nonetheless, choosing a color for our visualizations is of utmost importance and should be thought through carefully. In Matplotlib, we can change the colors of our plot by adding a color argument. Furthermore, we can choose a color name from a predefined color list available in the Seaborn library. Seaborn recognizes over 100 color names, starting from the basic ones such as red, green, or blue, which we can refer to by their initials, RGB, respectively. If you're feeling more adventurous, you can also choose colors such as linen, honeydew, or dark orchid. In fact, you can assign an individual color for each of the bars. Let's see how. We have 7 columns, and we'll assign each their own color. We can type in a string with the following 7 letters, RGBWYMC. Each of these letters is an abbreviation for a frequently used color. Here's what we get. Cool! Each column has been assigned an individual color. We have R for red, G for green, B for blue, W for white, Y for yellow, M for magenta, and lastly, C is for cyan. This shows how versatile plotting in Python is. We can specify a color for as many bars as we have in this manner. Just bear in mind the color abbreviations aren't limitless. Therefore, at some point, you might have repeats. However, in a professional presentation, we want our color to be uniform across the whole worksheet. Therefore, let's choose dark blue or midnight blue as the only color of our bar chart. You can find the full list of colors in this lecture's resources or check the Python documentation online. Okay, what's left? Well, every plot needs a title. To integrate a title, we type plt.title, and in brackets, specify the desired title. Cars listings by brand has a nice ring to it. Note that you need to put that in quotation marks so that Python knows that it is a string. Let's examine the result. While we've successfully placed a title on top, it is a bit small compared to the rest of the graph. But no worries, everything in Python is customizable. We can increase the font size by adding an extra argument, and then specify a font size of 16. We could also add a font weight argument and set it to bold. Here, we could also do with a y-axis label. To add one, we just write plt.ylabel, and in the brackets specify the name as a string. I know for a fact the axis label appear a bit smaller, so let's increase their size to a 13 with the font size parameter. In fact, let's also format the other text elements a little bit, so they look more pronounced. Increase the font size to 13 for the X and Y axis labels, and set the Y-Tix font size to be equal to 13 as well. Marvelous! Our bar chart looks presentation ready. A quick side note. Not all people are comfortable with coding in Python. In fact, you may often need to use your plot outside a Jupyter Notebook. To achieve that, you can export your plot as an image. This is easily achieved with the savefig method. In the brackets, we need to specify the name and file format. In our case, it will be a PNG, so we'll have usedcarsbar.png. And that's it. Great job, everyone! I'll see you next time. And thanks for watching!